The other thing that I want to also clarify over here, guys, and do that as another example, is this one. Your client, your FTP client, is making a connection to a FTP server on the outside on a non-default port number. Let's pick a port number. Let's say 1999. The class inspection, the default inspection class, which is called inspection underscore default, checks and recognizes FTP based on port 21. Okay, let me just put that out to you guys and then I'll write it. So this is the internet. I have a normal FTP server over here. I have another FTP server, which is only available to users that know the port number. This is IP address of 200.1.1.1, but they've changed the default FTP port number to 1999. This one is using its normal standard 21. This is my firewall inside. I have two FTP clients. FTP client 1, FTP client 2. FTP client 1 makes a connection to this guy. What's the destination port number that it's going out? Port 21. So because I have an inspection default which checks for what? Port 21, it says, oh, this is an FTP connection. I need to allow the return entry. And in that return entry, these guys agree upon a port number, let's say 15,111. So this one will automatically create an entry from where? 19.1.1.1, port 20, towards this, whatever FTP1 is IP address for what number? 15111, because it saw 21. But the second connection that I'm making over here is made to what? 19.999. He does not know it's FTP. He doesn't know that 19.999 is FTP. He recognizes FTP as what? 21. So he's not going to create the return entry for it. So this guy, although he'll log in, but he will not be able to transfer any data up or down. Why? Because the firewall does not recognize 1999 as what? FTP. It says, I don't know this port number. So if you have a non-standard FTP, what do you need to do? If your client is trying to establish a FTP connection to a server running on a non-standard FTP port, the firewall will not recognize it as FTP by default. You need to create your own class map to classify the traffic on port 1999 and inspect it as if it was FTP traffic. So basically, you're telling it to do it. All right? You need to create it. You cannot update the class map because the default inspection traffic, it'll only do it for the port number that I told you, this guy over here, see? It recognizes in the default inspection traffic, which is called inside the class map inspection default. It recognizes FTP as 21. Should be here somewhere, right here. So you cannot update that. You can create your own. So how do I do it? Let me do it here and then paste it. So I'll create a class map, non or NS FTP, non-standard FTP, match port TCP EQ. We said it was 999 or 1999, right? And then I can go into my same policy map. Which one? Global underscore policy, which is already applied. Call this class as well, class NS FTP, which matches, classifies traffic for port 1999, and tell it inspect FTP for, inspect FTP, that's it. Because I've already classified 1999 over there. It says if traffic comes in for port 1999, inspect it as if it was FTP. So basically check for the port number, create the return entry. Good so far, guys? So let's apply it. What happened? Oops, I didn't copy the whole thing. There you go. Class map NSFTP match port TCP EQ 1999. Call inside the global policy another class. So if you take a look at your policy map, global underscore policy, you'll notice that it has two classes now. It's going to check the inspection default. If it doesn't match, it checks this one as well. Got it, guys? And that is deep packet inspection for you guys.